Welcome to Wings of Arrow Advanced Education and Research Organization. To know more, visit our official webpage www.wingsofarrow.in. Hi guys, today we are going to see a shear flow and shear center foreign channel section. So first we'll see a shear flow foreign channel section. First you have to know this channel section is an symmetric section. Is symmetric about the x-axis. So you can see the dimension of a C-section. This is a cantilever beam. So we are taking a cross section of this beam, that is C-section. And here we can see that height of the web is h and the width of the flanges are b and the thickness of the beam is t, thickness t, and at the point, this is a point of shear center. The point at which there is a bending moment but there is no torsion or no twist at this point. So here the V is the shear force and the distance between the web and the vertical force, that is shear force, is E. The distance is E. That is a shear center distance, or we can also call as a center of twist. Now here how we are going to find the shear flow. So as I have said, this is a symmetric section. So what is the formula for the symmetric section of a shear flow? Q equals to V by I integral y t ds. This is the basic formula for an shear flow of an symmetric section. Now V is given, I is, what is I? I is an moment of inertia. And what is y? Y is a displacement or a distance of a member AB from the centroid. So we need to find the centroid. From here we can say that this is the centroid. So what is y? That is where a distance of the member from the centroid. So that is y and t is the thickness and ds is a change in distance. D is a change. Now we can find the shear flow for a section AB. Now what is AB? Let's name these elements A, B, C, D and E. Now we are taking this element AB. So let's write this QAB equals to V by I integral y t ds. Now here what we're gonna do, we know V and I. What is y? Y is a distance of the member AB from the centroid. This is for a common thing. That is, when you're considering the member AB, you have to consider that particular member. So here what we're gonna say that, what is y? Y is h by 2. So substituting here, V by I into T h by 2 integral of ds, we get as QAB equals to V T h by 2I into S. Now what we are going to do is, after that we are going to write at the point A. At the point A, now what is S? S is a distance traveling from the A to B. That we can say like here. So in here, in this equation, we can write as s equals to 0. Now substituting this s equal to 0 in this equation, we get as q at the point A, that is shear flow at the point A, equals to 0. Now at the point B, what happens? Let's see the diagram. At the point B, it is moving from A to B. So this B, what is the B point? Is B, small b. So we can write s equal to small b. Let's substitute the s equal to small b in this equation. So we get as VHTB by 2I. Fine. Now after this, let's draw the section. Now here at the point A, we have 0. The shear flow is 0. Now at the point B, we have some magnitude. Vertically upward some magnitude. Let's consider VHTB by 2I. This point is VHTB by 2I. Now see the equation here, we have some value in the linear form. So we will join this point and 0 point with a straight line. Fine. So this is the shear flow distribution across the AB. Now we are going to find the shear flow distribution across the BC. We will find till the C. C is the centroid. Shear flow for a section BC. Now for this section, what we are going to do? We are going to write BC equals to C. In this figure, what happens? We have found AB. Now at the B point, we are finding BC. So in this BC, the shear is flowing along the. So we can write QB plus V by I integral 0 to S y t ds. Now here, what is QB? Already we know the value of QB. Let's substitute VHTB by 2I plus V by I. And now here, what is the value of Y? Now here, what will be the value of Y we will consider? Here you see in the wedge, in this figure, we are taking BC. What is the Y point? That is Y. That is a distance of a member from the centroid. But the Y point is varying. Which point will we consider? So here, for simplification, what we will do is, we will take one small reference line. So from the reference line, we'll consider from the B point to this reference line is S, and this is a point is F. Now we will find a point from the centroid. So what will be the value? H by 2 minus S. So our Y value is H by 2 minus S. T is constant. Now what we are going to do is, we got this equation. After that, we are going to substitute at the point B. At the point B, again we are going to, this is our C section. We are going to start from here. This is our B and C point. So we are going to start from here again. So again we'll consider S equal to 0. And after that, we are going to substitute this S equal to 0 in this equation. And we get as QB equals to, again the same, BHT B by 2I. Now at the point C, The S is traveling from this point to this point. The S value is h by 2. Now we are going to substitute that value in this above equation and we can get that QB equals to VHTB. So first we got what is the magnitude of the BC point? We had VHTB by 2I, and here we have BHTB by 2I plus VTH squared by 8I. That means till here we have this magnitude, and from here what is the magnitude is VH squared T by 8I. And see the equation we have with that s minus s squared by 2. This represents a parabolic in nature. So we'll have a parabolic curve. Now see the BC is a replication of CD. So it will also will act in parabolic. And DE is a replication of BA. So here we'll also have the magnitude VHTB by 2I, and E point will be 0. So here we'll be having a straight line. So this is our shear flow distribution across the C section. Now the question is, which side it will flow? It will flow from E to A or A to E. See, this flow from A to E or E to A, it depends on the direction of the shear force acting on the body. So in this given question, it is acting vertically upward. So our shear will flow on the upward direction. So we have to write or draw the shear flow like this. Let me repeat again. This direction of the shear flow depends on the position on the location of the shear force. So if the shear force is directing vertically upward, so the shear will flow in this way. That means on the web, this lines and this line will be parallel and same direction and magnitude. If this is vertically downwards, then the flow will flow from A to E. But in this, it is flowing from E to A. So till here we have completed about the shear flow. Now how to find the shear center? To find a shear center, let's find the shear force of this particular cross section. This center region is the magnitude of VHTB by 2I, and till this point to this region is VHTB by 2I, and this one is VTH square by 8I, and similarly this one. Now what you have to do is, as per the definition, the force due to shear will be equivalent to the area of the shear flow distribution. There is a concept. So how to find the shear force? And we know that it is flowing from E to A. This B, C and D point. Now we know the shear is flowing E to A. Now this we need to convert their individual forces of this particular member. Now how we can find? The force due to shear is equivalent to the area of the shear flow distribution. Now let's consider this is 1, this region is 2 and this one is 3. Now let's find out the F1. What is F1? F1 is it is like a triangle. So what is the formula? Half B into H. So here, what is B? Half. B is the breadth or the width of this flanges. And what is the height? VHTB by 2I. So from here what we get? BHT B square by 4I. Now next comes F2. See, in F2 region, this is entirely, these are all our F2s, this shaded regions, full this area. Now to find F2, what is, we have a rectangular, one rectangular plus we have a parabola. So what is the formula for that? B into H plus 2 by 3A into H. Now let's apply. What is B? B is this VHTB by 2I. And what is H? H is the height. What is H itself? Then we have 2 by 3. What is A? A is only this major axis, semi-axis. So what is the value? BTH square by 8I. And what is the H? H is same. So H. So when you calculate this, we get as VH, here we have square TB by 2I plus we have here this combinations, we get as VH cube T by 12I. Fine, we get as F2. And this F1 and F2 are same, so we can write here this also F3. Now again recalling this question. In this question what is given? We have to find the shear center. Now let's take a moment about the shear center point. We have the F1, F2 and F3. Let's take a shear moment about the shear center. So we are taking a moment about the shear center point. So what we can get by recalling the diagram, here we have the shear center which is acting vertically upward. And what is moment? Moment is equals to force into perpendicular distance. Now this is our F1, F3, F2, right? And this is a distance E. Now what is our F1? How it is reacting on the shear center at the point? It is going anti-clockwise direction towards it. So it is negative F1. And what is a perpendicular distance? The distance between here to here is h by 2. So a perpendicular distance is h by 2. Now what is F2? It is going, taking the moment about the point E. So how it is going? Clockwise direction. So clockwise means we know positive. So F2, what is a perpendicular distance? Is E. Now F3. F3, it's going towards the point or taking movement about the point SC, that is shear center. So how it is going? It is again going in an anti-clockwise direction. So negative F3. What is the perpendicular distance? Again h by 2. So into h by 2 and equal to 0. So from this equation we can find that since F1 and F3 are same, so we can write twice of F1 equals to h by 2. So this 2 and this 2 will get cancelled off. So E equals to F1 h by F2. Now substituting the values of F1, F2 and h, we get as So what we have done is E equals to F1 H by F2. So we have substitute the value of F1 and F2. We have cancelled out the common terms, that is V H squared T from both the numerator and denominator, and we got this. From here we have taken, let's take further simplifications. We can take 3b by 6 plus h by b equals to, this is one of the expression. If we want further, we can also classify this as, if you take 6 common outside on both the numerator and denominator, you can write as b by 2 by 1 plus h by 6b.
Thank you for watching this video. If you have further inquiry or requested video, drop down to our mail wingsofarrow@gmail.com. Don't forget to subscribe for more updates. For the time being, take care, stay blessed, inspired, and fly high.